In this video, we're going to look at alignment and set alignment. These two operators are used to control how a particle is oriented in space and control his rotation. You can see we've got a particle draw with a geom instance, which is has this geometry that allows us to see which direction a particle is pointing. You can see this is the world axis helper down here, and the particles are all aligned to the world axes right now, so they have actually no rotation on them. Let's go ahead and this align dynamic set. We've got the all group and a couple disabled operators. We're going to look at those in a bit. But most importantly, we've got the alignment. And right now alignment is set to none. This drop down is the most important selector for alignment. It controls which method is used. If you see, if we select random, it's going to go ahead and spin them in all different directions. If we use direction of travel and we enable their velocity at birth, you can see on the alignment operator that the particle axis X is the one that's going to be following his direction of travel. We could set that to Y or Z, and you can see that as those particles move, the axis that's pointing down that direction is the one that we've specified. Of course, you can also invert that, so it goes the opposite direction. And let's go ahead and enable bubble motion. Bubble motion is going to have them, let's turn off invert. So you can see those x-axes changing around there as they move. And what we're going to do is actually take a look at this laziness setting. This is going to give them, obviously some laziness as they orient themselves. If we want a lot of laziness, it will take them a good amount of time to kind of point in the direction that they want to. In this case, the direction that they're traveling. Let's go ahead and reduce that. Next method we want to take a look at. We're going to skip the world X, Y, and Z. You should check the help file on that one. But the user defined is going to either use the to position input, or it's going to use this user defined axis here. We'll go ahead and disconnect this to position from that node, and let's go ahead and scrub. Let's take a look. Let's disable that velocity. And now what this is saying is I want to orient the particle's x-axis. I want to point that x-axis in this direction here, 0, 0, 1, which is Z, straight up. You can see that as we start to change that, first it's going to whip them around. So watch out for gimbal lock. And let's actually go ahead and see. We want to point the particle's x-axis down the actual world x-axis. And if we switch that to, let's actually make the particle's y-axis go that direction, or Z. And of course we could also add some variation, so it's not quite pointing in that direction. Okay, but just remember, if you do use this to position input, it's going to overwrite this user XYZ. So let's go ahead, oops. Okay, so what we want to do is actually take a look at having them move down the way without bubble motion, and we want to have them point at this point helper here, point 2. Let's make sure that laziness is turned off. Okay, and no limits. So their z-axis, particle z-axis, is going to be pointing at this actual position here the whole time. You can see as they move by. They are kind of small. Okay. Obviously with X, and if we invert that, and without that, maybe some variation. So they'll still kind of point in that direction, but not completely. Okay, so that's all pretty basic. What we want to take a look at now is having them track a moving target and look at limits. We're going to go ahead and set that node to be this moving node down here. So this guy is going to, let's turn off the velocity. This guy is going to actually move up, and you can see those particles pointing their y-axis in that direction. Because of the way they're rotating, you can see that they're rotating around their x-axis. Well, let's say we wanted to limit that x-axis and only allow it to rotate a certain amount. So you can see here in the beginning, only this guy is already kind of pointing that way, but these two guys don't rotate at all for the first few frames. That's because in order for them to do that, this object has to finally kind of come into their field of view. This limit is preventing them from rotating that far. And you can see that if we decrease, there we go. So this gives them a very kind of narrow rotation ability. And let's actually increase that so they can get quite a bit more. Positive rotation. Oops, not that one, but negative rotation this way. And then there's this X slide factor. X slide factor is going to give them some, it's almost laziness in this particular axis. So it's going to take them a while to rotate around their x-axis when they do this. Go ahead and set it to black there and white way over there. So what will happen is, actually let's add another key. We want kind of dark in here. So that you can see from the beginning, they start off pointing that way. They point down. And this is actually adding some kind of its own laziness to that x-axis rotation. It's most apparent there in the beginning. But this is good for large objects who have to track something else. It might take them a little while in the beginning to start tracking and then slow down toward the end. You can adjust that gradient for that. Okay, so that's set alignment. Let's actually set him to be none for the moment. And we're going to go ahead and use this set alignment operator here. We're going to change this around a little bit. We're going to use, let's unhide that node. Let's pick him. What we can do with set alignment, let's just go ahead and disable this. Set alignment is going to be using the alignment from this node and setting the particle's alignment to be the same as this. So you can see as we rotate this guy, those particles then update. As well, set alignment is going to give you the ability to add some extra rotation on top, as well as variation. And it can also work in conjunction with the actual other alignment operator. Let's say this was set to random. We're going to go ahead and make that a particles alignment to that. So now what will happen is it's going to go ahead and modify those guys. First it's going to go through this alignment, and then it's going to continue with this one. Add an extra effect on top. Then of course it'll add extra variation as well. Okay, so these are just kind of the basics of alignment and set alignment. You can see they have quite a few inputs available, and wow, yeah, lots. But definitely check the help file on these as well, and here we go.